EMG question of the day. Which of the following better represents leading trailing dipole brought about by an intracellular action potential in a denervated muscle fiber? Please take a few seconds to analyze the figures below and choose the correct one. Pause the video if you need more time, otherwise we will go on. In this frame you can see an innervated muscle fiber and its corresponding intracellular action potential. The intracellular action potential consists of a monophasic positive wave. The duration of this wave is very short, in the order of 5 to 15 milliseconds. This waveform can be conceptualized as producing an extracellular potential consistent with a quadrupole, which can be represented with plus and minus signs for positive and negative charges respectively, as you can see here, or as current in the volume conduction model. The arrows in the just added figure, regardless of the color, represent positive charges. The arrows' heads indicate the direction of the flow of the positive charge. So we have looked at the electrical behavior of innervated muscle fibers. Let's now look at the electrical behavior of denervated muscle fibers. In this new frame, you can see a denervated muscle fiber and its corresponding intracellular action potential. The potential consists of a long biphasic waveform. This waveform can be conceptualized as producing an extracellular potential consistent with an octopole. The initial positive phase of the potential, the spike, results from depolarization and repolarization of the cell membrane. This phase can be conceptualized as a leading quadrupole, which can be expressed in pluses and minuses, or as currents in the volume conduction model. The second element of this potential is a prolonged negative phase. This phase is made up by a relative fast hyperpolarization followed by a slow repolarization to baseline. This phase can be conceptualized as producing an extracellular potential consistent with a reverse quadrupole. A reverse quadrupole can be expressed as pluses and minuses, but with positive charges inside, as you can see here, or as currents in the volume conduction model with the same characteristic. Let me emphasize that the difference between the quadrupole and the reverse quadrupole goes beyond their length. In the leading quadrupole, the positive charges flowing away from the membrane are at the periphery, as you can see here and here. In the reverse quadrupole, the flow of positive charges away from the membrane occur in the middle. So the answer to this question is B. Just one more important thing. Please pause the video and read this paragraph. Once you have done so, play the video again. Now look at the figures in the lower part of this frame. These figures represent other forms of expressing the extracellular electrical activity produced by an intracellular action potential in muscle fibers. Notice that the length of the line expressing the extracellular electrical behavior of the innervated muscle fiber intracellular action potential, labeled 4.1e, is drawn using a 5 mm scale, whereas the length of the line expressing the extracellular electrical behavior of the denervated muscle fiber action potential, labeled 4.1f, is drawn using a 100 mm scale. Hence, the total length of the line in 4.1e corresponds to the length of the segment of the line enclosed by the vertical lines in figure 4.1f. Thank you very much for your attention.